All right, let's dive into this. Aluminum casting. So many people want to know more about it, and luckily we have just the thing. This guide, How to Cast Aluminum by Sunrise Metal.
Oh, yeah, this one is really thorough, very detailed.
So basically turning aluminum, the stuff in cans and foil into all kinds of complex shapes.
Exactly. And it's more interesting than you might think.
Way more. All right, so to kick things off, what exactly is aluminum casting?
Well, think about it like this. You're pouring molten aluminum into molds, but instead of like ice cube trays, you're creating these really intricate parts.
Okay, I'm picturing that. Yeah, like what kind of parts?
We're talking turbine blades, jewelry, really anything you can imagine. And the guide breaks it down into three main methods.
Oh, okay, so there's not just one way to do it.
Right. You've got your sand casting, which has been around forever, then investment casting, all about precision, and then there's die casting.
Die casting. I feel like I've heard of that. It's the fast one, right?
You got it. It's the high-speed champion of aluminum casting. Perfect for when you need tons of identical parts, like in car manufacturing. They use these permanent metal molds called dies and inject the aluminum under high pressure.
Okay, that sounds intense, high pressure and all. But how do they even make those molds?
It all starts digitally.
Hmm.
Engineers create a 3D model using, computer-aided design CAD.
Oh, so like a virtual blueprint.
Exactly. And then that blueprint goes to a CNC machine, which basically carves out the mold from a solid block of steel.
Wow. And is that it? Mold's done.
Not quite. Think of it like greasing a baking pan before you put the batter in. They apply a release agent to the mold.
To keep it from sticking.
Exactly. You don't want that aluminum sticking to the mold. It would ruin everything.
So mold's prepped. What about the aluminum itself?
Well, first you got to melt it. Aluminum actually melts at a pretty low temperature for metal, around 660 degrees Celsius.
Lower than I would have thought. So they just crank up the heat and...
Well, it's not that simple. Temperature control is super important here. Too cold, and the aluminum won't flow right. Too hot, and you risk damaging the mold.
Ah, okay. So molten aluminum, perfectly heated, ready to go. How do they pour it?
It's a very precise process. They use what's called a gating system, which is basically a network of channels that controls the flow of the molten aluminum.
Makes sense. No just dumping it in.
Right. It has to fill the mold completely and evenly, no air pockets allowed that would weaken the final part.
And then what happens after the pouring?
It's all about cooling and solidification.
Yeah.
And just like with the heating, the cooling rate has a huge impact on the final product.
Oh, interesting. How so?
Well, the way the aluminum cools affects its properties, how strong it is, how flexible it is. It's all about controlling the structure of the metal itself.
Huh. I never thought about it like that. It's not just about the shape, it's what's happening inside the metal, too.
Okay.
So it's cooled, it's solid, what's next?
Time to break it out. They open the mold and remove the casting. And depending on what the part is supposed to be, it might need some finishing touches, like trimming or machining.
So from molten metal to a finished part, wow. But why even choose aluminum casting in the first place? Why not just make things some other way?
Well, one big reason, especially with that die casting we were talking about, is speed. It's super efficient, which is huge for mass production. And then you have the cost aluminum is relatively inexpensive.
Right, so it's fast and affordable, anything else.
Oh, yeah. Think about design. You can make really complex shapes with aluminum casting, stuff that would be way harder to do with other methods. Plus, aluminum itself is pretty great, lightweight, strong, and doesn't rust easily.
So, versatile A&D practical. Okay, I'm seeing why it's so widely used. But we've only scratched the surface here. There's so much more to explore, starting with the method that's been around for, 6,000 years?
Yet it's sand casting, the OG of aluminum casting.
And we'll be diving into that and all the other methods right after the break.
All right, so we're back and ready to dig deeper into this aluminum casting world. Remember, we've got all these different methods, each with its own quirks and strengths.
Totally. And up next is the one with the most history behind it, right? Sand casting, the one that's been around for, millennia.
You got it. 6,000 years to be exact. We're talking way back, even before the pyramids.
No way! Seriously, that's insane. They were doing this back then.
Yep. Archaeologists have found evidence of early civilizations using sand casting, making tools, weapons, even art. Pretty impressive, huh?
Super impressive. But how did they even do it back then without all the technology we have today?
It was all about skill. You had these incredibly talented artisans who would carve these intricate patterns, usually out of wood.
Okay, so they've got their wood pattern, then what?
Then they take damp sand and pack it tightly around the pattern, basically creating a mold. Once the sand dried and hardened, they'd carefully remove the pattern.
Leaving behind a perfect cavity for the molten metal.
Exactly. Pretty ingenious when you think about it.
It really is. And that same basic method is still used today, right? Obviously, with some modern twists.
Oh yeah, for sure. We've come a long way in terms of the materials and technology we use, but the fundamental principles are surprisingly similar.
So, what are some of those modern upgrades? How has sand casting evolved?
Well, for starters, instead of just relying on wood for patterns, we now use a lot of synthetic materials. Stuff that's more durable, more precise.
So, the patterns are more accurate, which means the castings are too.
Exactly. And the mold making process has also gotten a major upgrade thanks to automation.
Automation? You mean like robots making the molds?
Pretty much.
Yeah.
Well, not robots exactly, but these sophisticated machines that can pack the sand, create the cavity, and even remove the pattern, all with minimal human intervention.
Wow, that's going to make the whole process so much faster, more efficient.
It definitely does.
Yeah.
But even with all this fancy technology, sand casting still has some key advantages that make it really appealing for manufacturers.
Like what? Why would someone choose sand casting over these other more high-tech methods?
Well, for one, it's surprisingly simple. The materials are relatively inexpensive compared to, say, die casting, which requires these elaborate metal molds.
So it's more cost-effective, especially for smaller businesses.
Right. And the process itself, while it requires skill, is pretty straightforward. It's very accessible, especially for smaller foundries or even hobbyists.
Okay, so it's cost-effective, it's relatively simple, but what about the quality of the final product? Can sand casting really compete with the other methods in terms of precision and detail?
It's a good question. And to be honest, sand casting might not be able to achieve the same level of detail as, say, investment casting.
So the surface finish might not be as smooth and the tolerances might be a bit looser.
Yeah. But for a lot of applications, it's more than good enough. It's a great balance between quality and cost effectiveness.
It's all about choosing the right tool for the job,
Yes.
right? Sometimes you need that ultra precision and sometimes you need something that's reliable and affordable.
Exactly. Sand casting definitely has its place, even in today's high-tech world.
Absolutely. Okay, so we've got a good grasp on the history and the basics of sand casting. But now I'm curious about the method that's all about speed and efficiency, die casting. What makes it so different from sand casting?
Well, think of it this way. Sand casting is like building a sandcastle. You create a unique mold for each part. Die casting is more like using a cookie cutter. You have a permanent mold that you can use over and over again.
So that's where those metal dies come in that you mentioned earlier, the ones that give die casting its name.
Right. These dies are typically made from hardened steel, and they're designed to withstand incredible pressure and temperature.
Okay, so they're super durable, but how do they even make these dies in the first place? It seems like that would be a super precise process.
It is. It all starts with a 3D model, usually designed using CAD software, just like with sand casting. But instead of using that model to create a temporary sand mold, we use it to machine a permanent metal mold.
So they're basically carving out the negative space of the part they want to create, but in super strong steel.
Exactly. And the machining process is incredibly precise. They often use these advanced CNC machines to get those really tight tolerances and intricate details.
Wow, so it's like a combination of digital design and high-tech machining. Pretty impressive. So once they have this die, what's next?
Well, before they can inject the molten aluminum, they need to prepare the die. They heat it up to a specific temperature to make sure the aluminum flows smoothly and doesn't solidify too quickly.
Okay, so temperature control is important here too. It's a recurring theme in aluminum casting, it seems.
It's absolutely crucial. The temperature of the molten aluminum affects its viscosity, how easily it flows. If it's too cold, it won't fill the die properly. It's too hot, and you risk damaging the die.
It's all about finding that Goldilocks zone, not too hot, not too cold, but just right. So the die is heated, the aluminum is molten and ready. What happens during the actual injection process?
This is where the real speed and power of die casting come in. The molten aluminum is injected into the die cavity under extremely high pressure. We're talking thousands of pounds per square inch.
Wow, that's some serious force. What's the purpose of all that pressure?
It ensures that the metal completely fills every little detail of the die, even the tiny nooks and crannies. That's how you get those really precise and accurate castings.
It sounds like a carefully orchestrated ballet of pressure, temperature, and timing. So the die is filled, now what? How long does it take for the aluminum to cool and solidify?
One of the coolest things about die casting is how quickly it all happens. The aluminum cools and solidifies incredibly fast, sometimes within seconds or minutes.
Seriously, that fast?
Yep. And that rapid cooling actually has a beneficial side effect. It creates a really fine-grained microstructure in the aluminum, which makes it even stronger.
So it's like speed, ND, strength,
Right.
all in one. What happens once the aluminum has solidified? How do they get the part out of the die?
Once it's cooled enough, they open the die and eject the part. And because the die is so precise and the cooling is so fast, the castings usually require very little finishing work.
So they might trim off a little excess material, maybe do a little machining, and that's it.
Pretty much. It's one of the things that makes die casting so efficient.
I can definitely see why it's the go-to method for mass production, but even with all these advantages, there have to be some downsides, right?
Of course, no method is perfect. One of the biggest drawbacks of die casting is the upfront cost. Those steel dies are expensive to make.
So it's not the most budget-friendly option for small businesses or prototyping.
Right. It makes more sense for large production runs where you can spread that initial cost over thousands or even millions of parts.
Okay, that makes sense. Are there any other limitations to die casting? Like, can you use it with any type of metal?
That's another thing to consider. Die casting works best with metals that have relatively low melting points, like aluminum, zinc, and magnesium.
So not so much for things like steel or titanium.
Exactly. Those higher melting points would require even more robust and expensive dies.
It's all about finding the right balance of cost, efficiency, and material properties. Okay, so we've covered sand casting and die casting. Now, what about that third method? The one that's all about precision and detail. Investment casting, right?
You got it. The method that's sometimes called lost wax casting. And it's a whole different beast compared to sand casting and die casting.
Intrigued. Let's hear it. What makes investment casting so unique? All right, we're back, and we've covered a lot of ground with aluminum casting. Sand casting, die casting, so much to learn.
It really is a fascinating process no matter which method you're looking at, but there's one more big piece of the puzzle we need to talk about.
You're talking about sustainability, right? Because let's be real, all this melting and molding, it can't be the most eco-friendly thing in the world.
You're right, it's not without its impacts.
Yeah.
But the good news is the industry is really taking this seriously and making some big strides towards more sustainable practices.
Well, that's good to hear. So where do we even begin? What are the biggest sustainability challenges facing the aluminum casting industry?
Well, the energy consumption's a big one. Extracting aluminum from its raw form, that bauxite ore, it's a pretty energy-intensive process.
Because of all the heat needed to melt it down, right?
Exactly. It takes a lot of electricity to run those smelters. And a lot of that electricity still comes from fossil fuels, which of course contribute to greenhouse gas emissions.
So even before we get to the actual casting process, there's already an environmental impact. What can be done about that?
A lot, actually. One of the most exciting things happening right now is the move towards using renewable energy sources in aluminum production.
Oh, okay. So instead of relying on fossil fuels, they're using things like solar and wind power.
Exactly. And that can make a huge difference in terms of reducing the carbon footprint of aluminum production.
That's fantastic. So that's the production side of things. What about all the aluminum that's already out there?
That's where recycling comes in. Aluminum is one of the most recyclable materials out there.
I mean, I always make sure to recycle my cans, but that's about it.
It's more than just cans. Think about car parts, building materials, all kinds of stuff. And recycling aluminum takes way less energy than producing it from scratch.
How much less are we talking?
Up to 95% less energy. It's a huge difference.
Wow, that's pretty amazing. So even though producing aluminum takes a lot of energy, we can really offset that by focusing on recycling. So what can we do as consumers to make sure that aluminum gets recycled properly?
Well, first and foremost, be mindful of what you're buying. Look for products made from recycled aluminum whenever possible.
I guess I never really paid attention to that before.
It's worth checking. And of course, make sure you're recycling all your aluminum products correctly. Don't just toss them in the trash.
All right, got to make sure it ends up in the right bin. So we've talked about energy use and recycling. What about the casting process itself? Are there ways to make that more sustainable?
Absolutely. Foundries are constantly working on improving their processes and reducing their environmental footprint.
Like what kinds of things?
Well, they're developing more energy-efficient furnaces for melting the aluminum and using less water in their cooling systems. Plus, they're finding ways to reduce waste and emissions during the casting process.
It sounds like they're really looking at every step of the process and figuring out how to make it greener.
Exactly. It's about continuous improvement and finding ways to make this essential industry more sustainable for the long haul.
So it's not just about making cool stuff out of aluminum anymore. It's about making it responsibly. That's really encouraging to hear.
Definitely. And I think it's important to remember that sustainability is a journey, not a destination. There's always more work to do, but the industry is definitely moving in the right direction.
It's been a fascinating journey exploring the world of aluminum casting, from the ancient techniques of sand casting to the high-tech precision of die casting and the intricate artistry of investment casting.
And we've seen how sustainability is woven into every aspect of this industry, from the sourcing of raw materials to the final products we use every day.
I know, I'll never look at an aluminum can the same way again.
Me neither. It's incredible to think about the journey it took to get there, from molten metal to a finished product, all while trying to minimize our impact on the planet.
It's a story of innovation, ingenuity, and a commitment to creating a more sustainable future. And that's something worth celebrating.
Absolutely. It's about finding that balance between progress and responsibility, and the aluminum casting industry is showing us that it's possible.
So next time you pick up an aluminum object, take a moment to appreciate the journey it took to get there and the people who are working hard to make that journey more sustainable.
It's a story worth knowing and a future worth supporting.
Thanks for joining us on this deep dive into the world of aluminum casting. We hope you've enjoyed the journey as much as we have.